Okay, so hello everyone. So this is a course DSAI 5101, so named as Statistical Data Mining. So, and I'm the instructor of this course. Today's we will, today's is our first time to meet, and today's content is mainly focused on the introduction of this course and also what kind of thing we will learn. So in this semester. Well, so maybe we just start from a brief, let me maybe we just start from a brief introduction about myself. Okay. So I'm assistant professor of the Department of Data Science and Artificial Intelligence, and I'm the program leader of the bachelor degree in this data science and analytics, so DSA. So probably some of you just come from the master programs, so master in DSA. So I'm just a leader for the bachelor part, and my background is mainly from the mathematics, and this is also some of my research interest. So like the machine learning and also some online learning, and also I also just have the new kind of research related to the large language model. So more personal information is just given here, and also you can find my email, and you can also. So once you have any question during this course, you can just feel free to ask me through the email. So first of all, so I would like to mention, so why I just put so many of my kind of like research information here. So probably you have know that for your program, so in next year, so you will have the option to take in the dissertation or not. Dissertation will just take like the 9 credit. So if you take the dissertation, so it's just the equivalent to taking the 3 courses. So here I just put some of my information. So if you are interested in just do a dissertations maybe next year. So if you also just find your research, if you find your interest is aligned with my research interest, you can ask me to as a supervisor of your dissertations. But of course, you probably know what is the purpose of the dissertation. So it's just to give you a kind of opportunity that you can do in some research project. So you probably that our aims maybe just trying to publish some paper. So it's commonly used for the student who want to pursue the further degree. Okay. So if you, in case you have interest, and also you can just find some of us other professors, some of maybe they are doing work with the natural language processing, or some doing the work with computer vision. So just depends on your interest. So this is just one opportunity. Maybe it's the first time you come to PolyU, and so so next year you will just meet this kind of option. So you can think about what is your future career. So just depends on whether you want to do the research project. Okay. So this is my some information about myself, and today's we will and also I just put the email, so in case you have interest, you can ask me after finish this semester, so we can have some talk if you want to just find a topic for the dissertation. Wow. And today's content is just have 2 parts. So we will first introduce the mean, so some kind of the basic information of this course, and then next we will go to the introduction, so about background of this course. Okay, so the first is about the time and the classroom for this course. So for this course, we will have the 2 parallels lecture session. So each of them are just contain 3 hours. So one is just the night of yesterday, and another is today's part. So these 2 class just share the same content. So if you unfortunately you just missing one class, you can go to another. But commonly, today's class is just the content is delayed to compare with the previous one. Okay, and so commonly for 3 hours, sometimes we will also contain the tutorial. So we will have the 2 teaching assistant. So but not every week we will have a tutorial. It just depends on. Okay. So most of the time, it's just maybe in total we will have the 4 to 5 tutorials in total, and each will just taking 1 hour. So maybe it's just for example, if our lecture is just taking the 2 hours, and tutorial will taking additional 1 hours. And here is also my office hour. So the office hour is just from after you can find it's also today's from 4:30 to the 5:30. So the office hour you probably know what is that. So it's just some open hours. So you can come to my office to ask me some question, or just also for some free discussions. So this is for the purpose of the office hour. So commonly every course will have such kind of office hour. And if you find this time it cannot match you timeline, cannot match your schedule, so you can also try to make an appointment with me, so through the email. So you can also choose some other times, but trying to make an appointment with me, so through the email, okay, to guarantee I'm in the office, okay. Well, so this is for the class information. So the next part is something probably you're most just concerned about. So it's about the assessment scheme of this course. So our assessment will contain the three parts with 20% from assignment, 20% from the test and mid-test, well, and 60% from the exam. So assignment in total, we will have the three. And of course, each will have some kind, around 2 weeks timed for submission. So, and the late submission will have some punishment. And we also have the midterm test. So because our course is a combination, so later on you will see what is the content. We will teach the method. We will also need to know how to implement the method. The midterm is a way that to test the implementation. So it will be it will become a take-home project. And also it's also a group study, and we will also require the in-class presentation. So the total evaluation will by 3 parts. So presentation, so it's a group presentation, and also some individual report to just identify your contribution for your group, and also some peer evaluation, which comes from the evaluate from your teammate. Okay, so this peer evaluation, so I have just taken for a long time. So it's just it's appears this part is very important, because sometimes the student will just worry about that their teammate does not make any contribution. So we just put this peer evaluation. Okay, so to guarantee that, so everyone should make a contribution to the team, and eventually will become the final examination, so which taking the most majority part, 60%. And for PolyU, there is some specific called the Rubik's grade cutoff. So if you have never just know this one before, so you can see here, I will just take some time to introduce. So here we have the 4 parts. So you can see ABCD is our grade level. So with the 65, 85, 70, 55, and 40 corresponding to the ABCD. So what does this stand for? So the 85 is just the cutoff between the A and the B. So the A category will contain 3 parts, like the A plus, A, and A minus. So this is stand for A category, and B stand for B plus, B, and B minus. So you can see you can find a score for assignment, find a score of your test, and your score of your examination, and then eventually it will give you a score. And your final level grade will depend on which kind of the category you will eventually fill in. So for example, if your score is around 88, so which means you should be in the A level category. So your score will just in either in A plus, A, or A minus. So if your grade is around 75, so it's just in the B category. So it will either be B plus, B, or B minus. Well, so this is the Rubik's grade cutoff. So every course in PolyU will just follow this Rubik cutoff. So if you are not sure about other course, just ask your instructor. Okay. So not every course just follow this one. So this is a standard one for the course. Okay. So far, any question? Okay. So let's just okay. So this is for assessment. So in case you have so group, last day, so yesterday, some student asked me about what is the capacity of the group. So it have not been determined. Okay, so it just depends on how many students will eventually choose this course. Okay, so we will trying to have I will trying to make the group around to make sure that we will have enough time to make the presentation in class. Well, and we will also allow you can make a group with a class 1 student. So you are class 2, and you can also make a group with a student in class 1. Well, so this is a full assessment. And another part is for the learning resources. So if you have you so when I come to this classroom, if you notice what I'm done, I'm just trying to log in this Blackboard. So this Blackboard is the main sources in the PolyU. So we will just most of our actually every our learning material will just upload it in this Blackboard. So including this lecture notes, we will also have the tutorial notes. And important, you can also say I just use the Zoom to recording this lecture. So everything here will just be you can eventually find on the Blackboard. So if you have not, if you forget, if you have not, if you still don't know how to use this Blackboard, just go to the Google. You can just from the Google search. Just go to the Google. Let me just back. Well, so you just search in the Google to trying to search this PolyU Blackboard, okay? And then you can find there is a platform. So it's our NER at PolyU. So you just click them and log in with your net ID, and then you can just find the courses here. And then you will have the several kind of courses, depends on how many kind of courses you will take. So here is our DSAI 5101. Just click and you can find just go to this web page and you can find there is a part named as a content. So maybe we can just go to the student part. So you can find there is a content and with the lecture notes and our chapter 1 and our chapter 2. And I will weekly upload this kind of the lecture notes. So just in case if you want to know this one in advance, you can just regularly check. Okay. Well, so this is a way. Let me just okay. This is a way that about where we can find our learning resources. And most importantly, so we will also have some announcement part. So this is some when something need to be highlighted, I will also just told you, and you will also receive a corresponding email. And for the course, we also have this textbook. So, but I just put it out here, but you can believe me, so the lecture notes is enough for you. Okay, so we just keep the main important content. So from the textbook and writing in the lecture notes. Well, and the cross outline, so it's just the what kind of thing we are going to talk about. So because our course is just somehow related to some kind of introduce some machine learning method. So of course, when we just want to introduce this kind of things, it's unavoidable that we need to use something from the math. So we will just starting with some preliminary things, so related to the math. So what kind of math course we will just kind of math content. So we will just mainly focus on two. So the linear algebra, so as well as our probability. So the two part. So we will not take too much time, just around 1 to 2 hours to have this kind of review. So in case you forget. So because most of the method, it's unavoidable that we need to use this kind of tool to introduce. And next, we will just focus on some kind of the method. So it's have the two parts. So the first part is regression and classification, so which we were going to talk about in the previous around 5 weeks. And then we will go to some like the clustering method and as well as some association rule analysis. And more importantly, we will also introduce how to make the practical implementation. And previous, I will just introduce some in the tutorial that told student how to just write the implementation. But this year, we will trying to make some change. So actually, we believe that it's not such kind of necessary to just told you how to teach the code. So now you can just use the large language model to generate the code. So we will just show you some demo how you use the prompt to just handle this type of question. So it's also just a part now people will call as AI for education. Well, so this is the main contents we will just introduce. And here is the overall summary for that. So it's an overview of what we were talking about. So so it's just in total, we have the 13 week. And today's will focus on the introduction and also the review on the linear algebra. And next week, we will just go to the linear regression as error analysis and some other content you will find. So some important part I just highlight with the blue and the red one. So blue one just corresponding to the assignment. So assignment 1 in the end of this month and another 2 assignment in the November. And the red one just corresponding to the midterm and the holiday. So there is one class will be skipped. So in the week 6, so it's just the mid-autumn festival. So if you can check that. So it's October 7. And also we will have the midterm will be, because it's a homework project, so its topic will be released after we finish the week 7, and also for 2 weeks. And 2 weeks later, we will just record for a presentation. Okay, so far any question? No. Okay. So, well, let's just move forward to. So this is the overall view of this course. Okay. Well, so in case you have some personal question, you can ask me during the break. Well, next we will just have an introduction of this course. And commonly, so we will use a 4 question to look at this course. So this course is named as Statistical Data Mining. So we will just starting from the brief introduction. So with a 4 question. So why the people do the data mining, and what is the data mining? And some histories about data mining, and what kind of method we will introduce so in this data mining. So actually, why the people do the data mining? So actually, I think it's a question so everybody can answer, because it's just so powerful that, because in recent year, so everybody just talk about this data science, talk about AI. So it's just quite close to this kind of the data mining. So they are also just the kind of part about in related to the data. So we know that data can just give us some information, can make something better. So here we will just see several examples. So why we need to do that. So first of all, viewpoint is very simple. It's just from the commercial viewpoint. So the money is the main motivation for the human. So at the beginning, so because you do the data mining, you can earn the money. So what is the initial this commercial comes from? So actually, so the data science just become famous, popular around 20 years ago. 20 years ago, how long it is. So at the beginning, so it's the first become popular is just from the recommendation system. Well, so what is so if I'm not sure whether you heard about, there is a computation. So it's just a computation so held by Netflix. So around 20 years ago. So in that kind of computation, so this company just call the people to, so you will have such kind of a data. So that every customers, so first of all, Netflix is just a company so that people can watch the movie. So you can watch the movie and you can also rating the movie. And this kind of computation is starting from they just show you some customer and also show their history behavior. So for example, what kind of the rating it give to several kind of the movie, and it ask us, so ask everybody to just want to find what is the underlying pattern. And they also just have some test data. So they want you just build some kind of algorithm, and eventually you can make a prediction on the test data. So this is just quite popular. So 20 years ago, so the winner will just win $1 million for that. And so this is just the initial of the recommendation. So the Netflix, you may just hear about is just a high tech, is a technology company. So it's just because it's the successful of their recommendation system. So nowadays, so for this kind of the platform, so they can just so you are the customer. So everything you do in this kind of their app, in their website, they can track everything. So they can track your rating, your rating score. They can track in your search, what you have searched, your watching history, and some other things. So everything you do, it can be tracked, because because their website just have kind of this kind of function, and once you do the action, so it will be recorded. And what we are trying to do is that we just want to know what is your behavior of the customer. And in that kind of a case, so if we find this customer just like some part of movie, so we can just recommend another part of movie. So if our customer could be attracted by our new recommendation, so our customer will pay for our platform. So the recommendation system is just built just based on this kind of logic, want to attract a new kind of customer and also keeps the current customer. So therefore, when you just look at their financial reports, there is a very important kind of this feature is that how many kind of the new customers just come to the platform. So because it's just corresponding how much money they can earn. So and how we just understand the behaviors of the customer is actually a part of data mining. So you can imagine that we have the huge amount of data. So every customer, every kind of this behavior they have to. So what we are trying to mining is trying to mine. So what is the underlying pattern, behavior pattern of the human or customer? So this is why we just use a mining to core to just core this kind of thing. So mine is just sometimes the people want to find the gold, so the mining. So that is the standard for the mine. But now the previous you just mine maybe on some mountain, but now you just have the huge of data. So it's also, if you look at the size of data, actually we have no idea about that. So we should understand it and trying to mine some things, dig out some things we want. Well, so this is initial of the Netflix. And also, if you look at, if probably some of you just use a TikTok. So the TikTok is also just be famous for its recommendation system, and also like the app, like the Xiaohongshu, so it's also just famous for its recommendation system. So it's also they also just told you how they just recommended something for you. So we can just look at what is that. So the first is trying to understanding your preference. So according to your interaction, so for example, what kind of the radio you just click, and then actually every video will have an underlying label for that. So sometimes like the cartoon, some like related to a game, some like to the supports. So the most naive kind of recommendation is just to give you the other kind of video with the similar kind of the label. But actually, so that kind of thing is very, very initial age. So you can see their third stem, we just told you that they will just pass on the label to make the recommendation. And then after they giving the label, and it's you as a customer, so you will also further give them feedback. So you will click or not, and they will just use this one to further adjust the recommendation for you. So this is a whole procedure. So you will provide the feedback. So even though you are passive provide the feedback, but they can just learn from your behavior and then eventually to give you some recommendation. So the underlying, so the commercial is also the same as the Netflix, just want to attract the more kind of the customer. Well, and this is just for the recommendation system, and some other kind of the data mining, we could just like a very simple example is like the fraud detection. So it's just to detect what is a credit card transaction is fraud, or just detect the email is spam or not. So at the maybe several years, just maybe in the last century, so it's just use some kind of use as some human to just detect. There are some kind of the employee in the bank, they need to just check every transaction record. But now we can just build some machine learning method. So it's just like it classify for a new kind of a transaction come. So you just need to classify whether it's corresponding to the fraud or not. So it's just we just point out here, and this can just it's also. So how we just do that is that we can also just trying to understand what is the behavior of the common user and what is the behavior of some other users. Okay, so it's just also a type of the data mining. Well, this is just for the commercial viewpoint, but of course it's also have some other kind of examples. So if you have interest, we can just feel free to discuss later. And another kind of thing is that, so it's just like from the scientific viewpoint. So actually nowadays you probably heard about a lot of name like the AI for science or AI for some medicine, AI for other things. But so this kind of thing is trying to combine the artificial intelligence so with some other, so it's interdisciplinary field. So a very, very important topic is that how we combine, how we use the AI, how we trying to understand our some things in the biology. So for example, like in the genomic data analysis, so we are trying to understand how the genes will just play a role in the human. So actually genes is pretty complicated data. So later on when we just introduce the background, we will just look at. So this genes analysis is just also started from the 20 years ago, and genes is just some part of sequence in the RNA. So, and if we can understand the genes for the human, and we can also understand how the diseases will come, some kind of the diseases, and we can also try to design the personalized medicine to just help the patient. And some other kind of the famous like the how to predict the climate. So climate modeling is also a pretty hard question. So actually, so if you want to predict the climate, actually this kind of thing can depends on lots of things. So it also depends on like the wind, like what is the temperature and some other things. So therefore but actually in totally we know it must come from a very complicated system. So what we are trying to do is that how we trying to understand this complicated system. So at a very so if we do not have this kind of data, so previously it's our scientists, they are trying to build a model. So they are just build some mathematical model or build some other model, trying to use a model to explain this complicated system. But now we can collect the data. We can collect what happens in the past. We can also have the corresponding what is the climate it will have. So we just use some more data driven paths to understand this question. So previously we just use our brain to think about trying to understand it, but now we just use data to told us. So we just use the data to find such kind of a corresponding model. So it's just the way why we call it as a data-driven method. And then also, when we're just trying to figure out this method, it's also figure out the corresponding model is also the part of the, you can see it's just want to discover the underlying patterns of that. So it's also the part of the data mining. And another kind of things I just would like to highlight here is also it's very hard to image. So maybe 10 years ago is that people use the data, use this kind of data mining technique to find the protein structure discovery. So you're trying to find what is the protein structure. So protein is an important part in our cell. So previously, there are a lot of kind of the paper published in the Nature Science. So the people are trying to find the new protein, want to explain some kind of functions. So what is the previous pattern is that the human or they just hire a lot of the postdoc or hire a lot of PhD trying to do some experiment. So do experiment and trying to find the new protein. So, and it will just, firstly, it will cost of time. And the next, it will cost of some money because the experiment require very kind of expensive machine. So this is the previous way that people to find the protein. But you probably heard about this kind of thing we called as the AlphaFold, so which was developed by the Google DeepMind. So it's just told you they can find the protein without experiment. So they do not have the experiment. They just trying to find the underlying pattern. So we know the protein is just generated according to the RNA, DNA. So if we can understand what is the underlying relation between the DNA and the corresponding protein, so actually we can just trying to design what is a corresponding protein. So and this experiment they just use this AlphaFold 2. It's not fold to AlphaFold. This is the second version. So AlphaFold, they just want to build the connection. So they have the two type of the data set. So one type is our genomic data. So just told you how the DNA or RNA or some other related thing will looks like. And it's also told you what is the corresponding protein will looks like. They just trying to build the connection between them. So it's a way that trying to find what is the underlying relation. So this relation maybe just it's just some models we will call it. So we just find a model trying to build a connection. And then if we can understand, if we have some gene, so we can, of course, to generate a corresponding protein. Well, it's just very hard to just image. So maybe 10 years ago. So how it seem could, so because if you know about this AI and also know something about machine learning, you know what is things about 10 years ago. It's just built on very kind of the ideals kind of the model. So like but if it's very hard to image that it can do this kind of complicated prediction. So because actually the human do not have any understanding about that, but you can do it just according to your own data. You can do that, and this one just become very popular just because it's wins the Nobel Prize. So last year. So you know, the first author of this AlphaFold, so who is a very young person. So he just get his PhD and then go to the Google DeepMind and trying to just involve this kind of the project, and then they just eventually find this AlphaFold. So I just want at this point I just want to tell you, so and not at now the current stage, so we are actually just at the, so AI is just at its initial stage. So there are a lot of things that we can explore. So therefore, so we need, what can AI become the kind of the so powerful, so influence is just because it's built a connection with other disciplinary. So like the biology, like the chemistry, like some other part. And so what I just want to emphasize is that, so you actually, so when we just learn this kind of thing, we also need to think about, so what we can do for it. So not just only apply. It also, so when we later on when we talk about some other method, I will also tell you some current limitation and for that. Okay. So actually we have a lot of things to do. Wow. And so this is just about some scientific viewpoint, and the people, I know there are lots of things which is underexplored, and it's just a time that we have a lot of place to do it. And this is just some things we can see the benefit from the AI, some benefit from data science. And also nowadays there are people also just with the rethinking about some side effect of the data mining, side effect of data science. So I just put at the end. So it's just like the ethical consideration. So nowadays we just have some issue like the data privacy, have the issue like the bias, have the kind of the issue like the transparency. So the data privacy. So even actually myself, so for most of us maybe think it's not a big issues, but actually I just give you example about this, how the data privacy, just the first that just caught the eyes from the human. So I just mentioned that, if you still remember, I just mentioned there is a game for the Netflix computation. So at the beginning, so I just go to this page. So I just told you there is a data set that told you there are some customer and what's the rating for the movie. But of course, you cannot know the name of this customer. You don't know the name. You just know it's an ID. It's just a sequence of number. But eventually, the people just find they can, according to the behavior, to detect the name of the customer. So that is, so this is why Netflix only have the first, they only just hold this computation one times, because the second time it appears that they can, according to the data, to detect the name of every customer. So how the people could do that? Because the human behavior so is just unique to you, unique to us. So even though we cannot notice that, but it's just unique to us. So they can know the behavior and trying to know who it is. So at this moment, the people just core this issue like the data privacy. So it's data privacy nowadays also very extreme kind of the hot topic. So in the field of AI, so you probably heard like method like the differential privacy. Are you trying to do that? So naively speaking, so you can hate the name of a customer, but actually it told you it's it's useless. So we can still know the name according to the data. So the data privacy is just told you like we can just change the data a little bit. So the data privacy is trying to change the data a little bit. I do not told you the raw data. I just make some adjustment, and I don't also want to influence the result too much. So this is a data privacy consideration. And also some bias from the algorithm, some bias from the data set. I'm not sure whether you have heard about some kind of the, so for example, when you're trying to do some, so we know the large language model is at the initial is invented by the OpenAI. And we can find, but now we also want to build our own large language model. So what is the reason for that? Because when they training the large language model, so most of article is based on the English version. So once you're trying to use some Chinese version, Chinese communication, so you will meet some trouble. So this is because the data set itself is biased. So we also needed to consider that. So when we're trying to, so this underlying bias from our data. And you also maybe heard about some old story like in the computer vision. So because when they're training they use a figure. Computer vision is trying to know what is a figure, makes the computer to understand the image. But some image is just itself is biased. So just because of this reason, so it's algorithm. So we need to rethinking about our algorithm. So rethinking about our data set. So some other bias it come, and also some other kind of issues. Just to become, it's just raise a lot of kind of things in industry, and also a lot of kind of the research paper for that. Okay, so this is just because the things will have always have the two side. So it's so powerful, and but meanwhile, it's just depends on whether it's so powerful. Sometimes it maybe hurt ourselves. Okay. So this is just the reason. So why we just use this data mining. Well, just to give you a formal definition for that. So data mining, so is a core component of the data science. So which enabling the automated discovery of patterns. So this is something we have just mentioned a lot of time, but as of course it's too abstract. So what is a pattern? It is the discovery of the trend relation in massive and complex data. So, and it's leverage the statistical method, so machine learning algorithm, deep learning algorithm, and the domain knowledge to turn the raw data into actionable insight. So some key things you can find. So it's in addition to some statistical method, machine learning or deep learning method. So it also you need to have some domain knowledge. So for example, if you ask me to just handle the biological data, I never studied biology before. I can even know I cannot understand this. What is the relation between the DNA and also protein? So of course you don't know what kind of data set you should use and what kind of relation about them and how you build your model. So therefore, the domain knowledge is also a key part of the data mining. So it's just not only learn some machine learning method, deep learning method. It's also important for us to just have some domain knowledge because every data set is have its own story. So you should understand its story and also just know what kind of method you could use. Well, so this is about the definition for this one. Okay, so far any question? Well, next, we just look at the history of the data mining, okay, and AI. Let's just look at history. So this kind of things is just this history is just it's not too long. So this AI, so the name this of artificial intelligence just happens around the 70 years ago. 70 years ago. So this first artificial intelligence is around just be proposed around the 1950, and so the famous guy you probably like the Turing. So they have just developed a Turing test for, and it's just proposed this artificial intelligence, and shortly, so there are some kind of big event I just highlight for you. So at that moment, so when the AI is proposed, the people want to try to find the AI, and most of the people believe they could do it shortly to find the artificial intelligence. But we know until the current day, we still do not have such kind of the intelligence. Well, so there are some kind of the big kind of the event. So in the 1958, so there is a person called the Rosenblatt. So invents the precision. So it's the first artificial neural network model. So do you know what is the precision it is? So probably not, but you probably heard about like MLP, so which we call as a multi-layer precision. So it's just a single layer precision. So the most naive deep learning method, multi-layer precision. So it's just come from this precision. So it's just like the one hidden neural network. And later on, so there is something called as a symbolic AI, so which focus on the logic and the rule. So it's not learning from data. It's just like when at the beginning, the people trying to, so because at the initial, you can find AI is may not such kind of related to the data. So AI is artificial intelligence is just like it's just like the intelligence developed by the human, so called as artificial intelligence. So at the beginning, the people try and use some logic or rule to design what is the AI. So for example, I just told you, in some kind of a case, what you should do, in some kind of case, what you should do, just based on this logic and the rule, you can hopefully we can find such kind of AI. So this kind of thing is not from trying to learn something from the data. But shortly, so this kind of thing is very, very limited. So because this limit of data and also the computing power is cannot handle such the complex kind of the logic and the rule. So it's just shortly comes from the things called as the AI winter. So it's so the AI winter is just a standard for the case. So at the beginning when AI just come, so people will be excited about that. So there just occur a lot of people to invest on the AI, just a lot of money come, but shortly they cannot find any expected outcome. So the money just out. So it's just nobody invent about that. So it's just called as the AI winter. So this is our first AI winter. So in the end of the 1970s. And next is just some renaissance of the AI. The renaissance of AI is just back. So in the 1980s. So it just have some breakthrough. So in the 1986. So Hinton, you must know who it is. So we just call it as the father of AI. So it also just gets the Nobel Prize. So last year, so in physics, and it's popularized the back propagation. So which make us can training the multi-layer neural network, or also the things we call as a multi-layer precision. And but back propagation itself is just not invented at that time. It can just back to around the 1950. And also at this time, it also just built some rule-based AI system, so called as the expert system, but probably most of us have never just heard it. It also be used in industry. It can handle some very easy tasks, but the bad thing is that, so based on this rule-based, so it's not flexible. So it's a brutal and hard to scale. And shortly, so just for the same reason, so it attract money and eventually find it cannot as a truly AI. So and then it's just go to another AI winter. So in the late of the 1980s. So we have already just passed the 2 AI winter. And then it's just becomes near just the end of the 20th centuries. So in the 1990s. So it's just the emergence of the machine learning method. So it's just come from this data mining and the machine learning. So data mining just become a popular term. So we can just think about how so at that moment, so there are a lot of kind of algorithm we will just nerve in this course, like the decision tree, like the random forest, like the gradient boosting, and also k-means, a priori algorithm, and also the support vector machine. So at that moment, it just offers the new things, new ingredient to this data science. And at that moment, it's also because the emergence of the internet. It's just for this reason we can have the data. So you can see this kind of opportunities is just come from the 3 part. So is one of the things is that the development of the new hardware and the software, and also the internet emerge. So that give us more communication that we can have the data. And also, meanwhile, we have some basic machine learning method can help us to handle the data. So at this moment, you can find, compare with current deep learning method. So this method does not require too much computational resource. And then we just go to the years about these centuries. So we just mentioned, so around the 200 and 2006 or 2009. So there are some kind of computation. So in net physics, so recommendation system is first to go to its pay. It's just become popular. So it's just we have just introduced what is that. It's just a nerve from the data, so nerve from the behavior of the customer. So just can make some recommendation. But at that time, so if you heard about the method used in that time, it's called as a collaborating filtering. So it's just like the way to analyze the metrics. And also, meanwhile, so this bioinformatic data we have. So at this moment, there is called as a kind of a project called as a human, so genomic project is trying to understand, so what is the genes within the human. So just to detect every gene. So this at this moment we also have the huge of data. So to understand what is the biology information in the human. And also, meanwhile, so there is some open source tool. So that make everybody can touch the AI, can touch the, it's actually not, I do not like call it AI, just call it touch the data science. Well, so compared with the previous, so most of this method is still just in the academic, in the industry. But once you have more open source, so everybody can touch it. And the deep learning become the extremely popular. So it's just because at this moment, so the 2012, so there is also a new computation. Is computation above the ImageNet. So it's just they just developed something called AlexNet. So it can just the domain and also can just beat every machine learning method. So AlexNet at the current day, we will say how it's a very huge model. So, but of course, it's not comparable with the large language model. So it's a huge model, and it can just ImageNet is just at this moment. So it's a core. So it just makes the computer vision. So this field extremely popular. So you can see a lot of kind of the good work. So in near 10 years is related to this computer vision. So computer vision is just trying to make your computer to understand the image. So ImageNet, you probably have just touched before. It's just to give you some figure and you need to detect. So what is the animal? What is the kind of item in this figure? So this is the ImageNet dataset. So AlexNet just based on some convolutional part, it can just help us to understand it. And also, I just missing one part. So it's also the successful of the AlphaGo. So the AlphaGo just it's just the algorithm that can play the Go, and nowadays no one can beat it. And also at the end of this 2010s, some things you probably just know they pretty popular. The transformer just be invented, and so it's help us to at the first stage trying to make some process in the natural language processing, trying to understand the natural language. And so actually, so if at the current year, so at the nowadays, so in these 5 years, the most successful things is the emergence of this GPT, so large language model, and also some other kind of this large language model, including and also some other large, how to say, large vision model, the stable diffusion kind of model. So you can just make the AI to every people. So previously, if you have not touched the AI, so you probably do not know anything I just mentioned here. But now everybody know the GPT-4, everybody knows the DeepSeek. So because it's just brings the new kind of things to the human, and we just find this thing is so powerful. But actually, so before the GPT is invented, so you can just back to 3 years ago or 4 years ago. So people will just think about if you just ask some data scientist, so they probably will tell you we are just at the bottleneck. So we cannot find any breakthrough. So people just worry about another AI winter will come. But things will just change because of the new things come. So it's our large language model. And based on this model, we can build some kind of, you can heard about like the embodied agent. So it's just a AI powered robot, and also some other, just because of this large language model can help us. So it's important because it makes the machine or computer to understand our human language. And and also just to give us more kind of things. So it's just to bring like the AI powered chatbot. So we just mentioned. So it's related to the embodied agent and also some auto vehicle. And at the meanwhile, so this we just mentioned there are some other core just people find so powerful, and they just consider some new ethic issue like the privacy we mentioned, like the fairness we mentioned, and also some other just big company just provide the cloud computing and open source framework that make everybody can try to train your own language model, training your own deep learning method. Okay, so this is just the whole history we just look at. So actually so in my mind, so I just mentioned that. So previously that we just so I just told this course around for 3 years. So previously, so we don't have such kind of the GPT part. So when I just told my students, so I asked them to rethink about the AI winter. But now I don't think it's a big issue. So actually, this large language model can make this AI at least can just be popular for a long time. Okay. And here is just the whole kind of the main timeline for the data science and AI. So we just highlight part of them. So if you have interest, you can take a look. So like the precisions, this precision will develop at this time, and the first AI winter, and also the second AI winter is come from here. And also nowadays we have the GPT. So it's just to make AI to everybody can accessible to this artificial intelligence. Okay, so maybe we just take the 10 minutes break. And after break, we will just look at so what is a method we will introduce in this semester. Okay, so let's just back to our class. Well, there are still, so we have just to see some kind of things mentioned. So, but actually I also mentioned as a meanwhile, there are a lot of things we can explore. So in the future. So there are some kind of challenges I point out here. So we just briefly look at them one by one. So here I just sum a few of them. So the first thing, some kind of challenges we probably will meet is the first thing is called as a scalability. So the scalability is trying to stand for the ability to handle the massive data. So like the social media platform, so it now have the process, so millions of the post, image, and audio every day. So actually this kind of data is generated so at every second. So it's just a large amount of data. But unfortunately, so we do not have such kind of powerful method to analyze this kind of the data timely. So this is just because if you have trained your own model, you probably know that when you're trying to handle this issue, so if we give you a huge large amount of data, so if you want to train your own model, it will take a lot of time to do it. But like the social media platform, sometimes you want to detect some new kind of news, so that will require to give you a timely feedback. So how to handle them is still a big issue for that. So give your scalability to handle the massive data and also give your timely feedback. The second thing is called as a high dimensionality. So the high dimensionality is stand for the dimension of data is large. So for example, when we're trying to discover the pattern, so some relations. So sometimes we want to discover the relation between the genes and the diseases. So genes is actually is a very typical high dimension data. So we can have the million of genes. So within our cells, and we want to detect them. But well, so our data is looks like the representation of the genes, the representation of genes. In the common genomic data, it contains a million of feature per sample. But as a meanwhile, we may not have such huge number of the sample. So because when we just collect the data, so the data you should do the experiment, and it will cost of you just also still at the meanwhile you need to some expensive machine to do that. So commonly we do the sample size is not large, but the feature is large. So this is a typical high dimensional problem. So and what kind of things we should do. So later on, so we could probably think about, so like in some kind of data, so that we trying to detect the genes of the in every cell. So for a cell, we can just find the gene. So it's a million of dimension. And but how we just analyze this kind of feature. So we want to know what is the relation between the cell, what is the different category of the cells. So commonly the people will just use the dimensionality reduction technique. But well, it's just like the principal component analysis or some manifold learning. It's so basic one. So actually, there is no kind of the golden rule for it. So even the start art of the biological analysis with the artificial intelligence is still uses high dimensional is dimensionality reduction technique like the PCA, like the UMAP, like the TSNE. So the commonly used way. Well, so it's a still big issue, and it's still underexplored to what kind of good method to do that. The third thing is called as a heterogeneous and complex data. So it's just because the different source of data and also because the different type of data. So sometimes data will become like the audience, sometimes the audio, sometimes like the image, sometimes like a video, and also different type of data come together. How you make a good kind of the model to understand it. So commonly, so if you look at our method, so most of the method are just based on some ideal case, just to tell you how you handle the image, how you handle the audio, how to handle video, how to handle the categorical data. So this kind of things is it's very hard to if you want to combine everything together to have a good result. So it's just come from the heterogeneous and complex. But in reality, so the method we introduce is most on the ideal case. Like every machine deep learning method, you can definitely try it. So, but if you didn't handle your raw data, So if you try any method, it cannot give you any good. You cannot expect a good result. So some heterogeneous, because this is just because when they introduce the methods, their data maybe is just in some good manners. So rather than it's heterogeneous and complex, but in reality, the data itself is just look at this like the heterogeneous and the complex. And the third thing is like the data ownership and distribution. So something we have mentioned that like the data privacy. Well, just the consideration of the protecting the privacy, and also sometimes there are also, if you just have a collaboration with a lot of companies, they do not allow you to take them data outside. You can only use your model trying to train on that data, but you cannot take the data outside. So it's just because of ownership. So and some kind of way to handle it's like the federated learning. So just to combine the different mode together, you don't need the data, you just need the algorithm and how to combine together. Well, so this is some current some current challenges, and of course there are so many. So we will just also free to discuss. So we can, and you can actually, we have lots of things we could do. Well, but this course is just as a preliminary course. So we just first so the aim of this course is trying to, I forgot to mention. So it's just trying to, we will introduce some method, but most importantly, we will trying to underline the logic of the method. How the people, what is the idea they propose this kind of method? So what is the underlying thinking? What is the underlying the way that they develop this method? So this is something we need to learn. So just a sense to understand it, a sense to understand them. And the second thing is just how to implement them. Okay. And this is just some other, probably in reality you could meet, and also how to handle them. You should develop another kind of way to do that. Well, so some kind of method we will talk about is just fulfill in these two categories. So the prediction method, as well as the description method. So prediction method are just commonly we have the two topic, so classification and regression. And the description method we have the clustering and the association analysis. So this is some things how we do that. Here we just mainly focus on this four part, but of course there are also some other kind of the small kind of category. So if you have interest, so if we have enough time, we can just introduce some more. Wow. So let's just look at them one by one. Okay. So we first focus on the prediction method. So if you have touched them, if you have learned something about them before, so you probably know what I'm trying to do. So, but if you do not, you can also at the first time to think about what is the problem, what is the problem it is. So so the first thing we will meet is called as a classification. So how we formula a classification problem. So in the classification, so we are trying to learn from data and what our data it is. So here I just use some mathematical formula to stand for the data. So our data is given here. So it's xi and yi. So I stand for from 1 to n. So this stand for, in total we have the n data. So first data will be x1, y1. Second will be x2, y2, and xn, yn. And x is something we call it as a feature. So it's just from some space, from some state. So like this x could be like the pixel of the image, could be like the video, could be like some other kind of type of feature. And the yi, they stand for the labels of the data. So naively speaking, so for each kind of x, it will corresponding to a y, and a y is either be -1 or 1, stand for the different category. And the classification problem is just based on the idea that we believe that the x have some kind of the key component that contributes that eventually y will become to the -1 or 1. So commonly we will see the -1 maybe as a class 1, positive 1 as a class 2. So we believe there are some kind of pattern. So that make our x to become the class 1 or some pattern in the x to make it become the class 1 or class 2. And our task is trying to find this pattern. So mathematical formula will say that we're trying to find a function f. So the f is just like the pattern we want to discover. So it's just mapping the x and to the data set, -1 to 1. So if we hopefully we can find this f, so we can when a new data come, when there is a new things X come. So we can just have some analysis about, so what is the corresponding class it should be. So for example, if fx told us it's more close to 1, it's just become our class 2. If fx more close to the -1, just become the class 1. So it's just so this is and this is a classification problem. So it's just giving some feature, and we want to know whether it's in the class 1 or class 2. But of course, there are some multiple class. So for example, if you want to just put the make some category for the animal, so animal will have the so many kind of the class, and when you do that, so you will have the multiple class, like it's a rabbit, it's a mammal, it's an insect, it's also some birds. So just like the figure I point out here. Well, so it's so naively speaking, so the classification problem is trying to understand the feature and know what is the feature is corresponding to the class 1, class 2. So later on, we will see we can compare with the regression problem. So the key important things here is that, so the yi here is that the yi just does not have any mean. It just use a distinguished number to stand for they are corresponding to the different category. So for example, this yi equal to -1, if it's just stand for, there are several kind of data. So if they are both of them in the -1 with the yi equal to -1, just stand for they are in the same category. And if not, they are just stand for they are in a different category. And the class here is just so just like the image computer vision we mentioned, some example like the computer vision. So given your pixel, like the minister data, there are some hand digital writing. So with the 0 to 10 or 0 to 9, and you need to ask a computer to know what is the number within this digital writing. So, and at this moment, the X is just every pixel. It's it's the black white version, so it's pixel with a 0 and 1, and also like and corresponding Y is just a multi-class classification. You should, when giving an image, and you should told me whether it belongs to the class 1, class 2, class 9, or class 0. So that is a very typical classification problem. And some more kind of mimic example, like, so what is just the corresponding to my kind of research part. So just like our team just do some like the support analysis. So support analysis is the main purpose is trying to make the prediction on the incoming computation. So you can image that the support is just the computation between the two team, between the two player, and the X is just the feature of the team, feature of the player, and the Y is just stand for maybe yi equal to -1, just to stand for the first team lose the game. Yi equal to 1 just to stand for the first team just to win the game. So we can of course in the support analysis we have this kind of data. We know which two teams compare and what is their corresponding result, and we are trying to understand how the feature of player contribute to the win or lose. And this is just the binary classification for the win and lose. And also in the football game, like just in addition to the win and lose, we also have the tie. So that is just standard for the two teams have the same score. So there's no winner and loser. So that is a multi-class classification problem. So actually classification is just is just a way that you want to, there are several possible outcomes, and you just need to predict what is the outcome it will eventually have. Well, so when we just talk about regression, we will see more kind of difference between the classification and the regression. Some kind of the example we have mentioned, like the fraud detection, is just a way like the classification. Actually, I just mentioned before. So it's just a given some transaction record. So about this credit card. So you can actually, when you do a transaction, you have some information. It could be collected by this bank holder, collected by this bank. So like which kind of thing to buy, and what is the amount of that, and what is the time, and where it is by. So, and we can just record the whole kind of information from every customer, and then we can just have a data set. And so therefore we have the X and Y. Like X is what is the transaction, some information about transaction, and Y is whether this transaction is fraud or not. So then we can just build an algorithm to find classification algorithm, trying to find whether given whether how the xi is contributed to our yi, and eventually when a new kind of x come, so we can make a timely feedback for that. So for just a brief summary, so it's just the goal of the classification is assign an item, so given its feature, to some predefined category or classes. So we have just mentioned like the detecting the spam email and also denoising the disease and diagnosing the diseases from medical image. So just like the computer vision, the previous computer vision is just like the minister data I mentioned. Now it's also just bring some new kind of application to the medical part. So like the X-rays and the MRIs. So it's just X-rays is just when people go to the hospital, the doctor will ask the patient to just take these X-rays. It just can told you some kind of the information so in your bodies, but but people just sometimes we're trying to, if we can just use a computer to first make this kind of the adjust this kind of classification, we can know. So when the no, just back a little bit. So when the doctor just asks you to take this X-ray, so ask the patient to take the X-ray, and then after it take it, so it will ask the doctor to just see these X-rays and to see whether the patient have these corresponding diseases. So this is a common way. So that when the patient go to hospital, and this is a common procedure, but people just rethinking. So whether we can use AI to replace the doctor. So because actually, when it takes the X-rays, is the doctor is well trained and also the experience, so they know what is the underlying information within it. But unfortunately, so to best of my knowledge, so there is not such kind of powerful AI to do that. So there are some kind of the AI can under some do good on some specific work, but it cannot be better than a well trained and experienced doctor. So the main kind of the gap is just behind. So one thing is that we may not have the enough data. Another thing is that we may not have, so for the data scientist, so we may not have the domain knowledge. We can just ask the computer to use some convolutional neural network to understand it. But if we can have some domain knowledge, we could do better. So this is some not such kind of the good explored kind of the field. So just like the diseases, diagnosing the diseases, but it still can just be, it's still a part of the classification problem to judge. So giving a X-ray picture to see whether it has diseases or not. And some other example like the classification for the spam email, and this is just a very, very popular ones. Okay, it's just quite easy to do that. And in our course, we will just focus on some kind of method, including like the decision tree, support vector machine, and also the neural network. Okay, so far any question? So this is for the classification problem. And another thing is commonly very close to that is called as a regression problem. So in this case, we also have the data like the xi and yi. But x is still stand for a feature, and y is not only the -1. It's just become some real value. So y belongs to r. So this r just stand for the real value. And at this time, we also believe that x can contribute to our y, xi can contribute to our yi. So, and our task is trying to find a function. Also the same, you can see very close to that, close to the classification problem. We want to find f to mapping our xi to the yi. So, and then when a new data comes, so we can also make the prediction on the corresponding y. When new data x come, we can also use the fx as a prediction for the y. So this is pretty close to our classification. So we first look at some example, and then we just compare what is the key different. And also just the corresponding method is also different. Well, so the obvious kind of the difference is come from the value of yi. So in the classification, yi just equal to -1 or 1 or some other kind of integer. But here yi can take any real number. So the key difference is just come from this yi. So what kind of yi we can have in reality? So here are three examples. So for example, the yi could be horse rice. So we can make a prediction on the horse rice that and our feature could be like the location, size, and age. So because when we consider the horse price, this price is just a continuous value. So it's just become some real number. So we cannot treat this guy as a classification problem. So because it's just yi just can take in the any continuous number, so we can just treat this one as a, so this is just a typical regression problem. And also like the climate, such kind some like the climate predictions, there are some also example related to could be regarded as a regression problem. At this moment, our feature could be like the temperature, like the air pressure, and some other things. And most famous kind of the regression problem is just trying to use in the finance. So the people are always trying to do some stock price prediction. So and in this is also a type of the regression problem. In the stock price prediction, so the data you have is that, so for every single stock, so you know what is the current price, and you want to just make a prediction for its future price. So you have some feature X, and what kind of feature you could use? You can use a historical feature. You can also use some real-time financial data. So trying to make the prediction on the stock price, and because the price is also a continuous value, so it's also a regression problem. So we just want to find our X, collect some feature, and want to find a mapping F to making our X belongs to the Y, equal to the Y. So and this is just so but unfortunately, if you just know this area more, you cannot find a good model for that. So commonly, it's not a good way to make a. Later on, we will see what is the main kind of the problem. So within this kind of the financial data, so it's just because it have some too many noise. That once you want to use a more advanced model, you will just go to the some wrong direction. Just the more advanced model, just maybe you go to the more wrong direction. Well, and the technique, some kind of method we will introduce to handle this prediction. A regression problem is like the linear regression. So we will talk about next week, and the ridge and the lasso regression, also the neural network method. So, but the ultimate goal for the regression is trying to predict a continuous value based on the feature. So we can compare the difference between the regression and classification in that. So classification is focused on assign the item to the category. So here we also, even though I have the yi equal to our yi have some value, but I never say that we want to making our fxi to equal to some yi. So the reason is just because the yi belongs to 1 does not stand for this, the corresponding value is equal to 1, just stand for, it just belongs to the 1 class. Class 2, y equal to -1 just stand for it belongs to class 1. Actually, it does not give us information about, so it does not have any numerical value so about this yi. So it's different compared with the regression where yi actually itself has the value, have the meaningful to that. So like the price, like the house price, like the stock price, it's just have some information for that. But in the classification things, yi equal to 1, it does not stand for the corresponding things equal to 1, just stand for they are in the same class. So this, we just use a distinct number to stand for they are in the different category. So 1 or negative, you can use a 2 or 3 rather than negative 1 and 1 to stand for the different labor. So it's just trying to distinct, so stand for they are in the different category. So later on you will see, when we just handle this problem, there is a very kind of the good way to rethinking this problem is that we never trying to make the prediction, find a f to make the fxi equal to yi. We never trying to do that. So we are trying to do, we are trying to use the xi map. We're trying to find a function f to mapping the xi equal to the probability of yi equal to 1. So we just mapping xi. We just build this function f corresponding to the probability that yi equal to 1. So you can find Compare with a regression problem that we are trying to find f to mapping the xi to y. But for the classification problem, we're trying to mapping the xi to the probability of yi equal to 1. So this kind of the probability thinking is very just be pretty important in the data science. So this is the reason why we also need to know what is the probability, because we believe everything could be random. So like the supports analysis I mentioned to you. So even the two teams, they have the same feature, but sometimes it could be win, sometimes it could be lose. So which means that even given the same x, it could be sometimes equal to -1, sometimes equal to 1. So with this type of consideration, so you should involve the probability to describe this kind of randomness. So of course, if it could not be a deterministic way. So in the case I mentioned, so if your data have the same x, just a mapping to the different y. So you cannot find a golden f to mapping the same x to the different y. So this is just and this probability thinking will also involve a lot of methods we will introduce in this course. Okay, so this probability thinking also just can just this is just a new kind of sense when we just trying to analysis the data. Well, so this is for the classification and the regression. And the third thing, next thing we will talk about is about the description method. So the first thing is called as a clustering. So here we just look at one example. So there is an example like there is a baby that play a sand. So with a lot of tool. So in your left part, and there are a lot of tools she just used to play. And her father just so after he play just to ask her to clean up. So and her just do this type of the after this type of the clean, and she just puts the same tool. So in the same column. So like this, you can say this thing is just very similar to others. This thing is similar to others. And there are some kind of the cartoon card. So she put it together. So this is the way that she just clean up this kind after she playing. So this kind of the things it just told us actually. So when ask, so we can find itself she itself just make this kind of the classification without any instruction. So this is also the way. So because when we're trying to do something related to artificial intelligence, we should first understand, so what is the intelligence itself? We just find a human have this nature that we can do this kind of classification without any instruction. So for a baby, she can do that, play the same things together. So this type of the problem we just call as a clustering. So that is standard for this type of problem. So is that, so we only have we have a set of the data point. So and this data only have the feature, only have the attribute, and we wanted to make we want just to make some classification on this data. So compare with the previous classification problem. So we know what is the x and what is the corresponding y, but in most of the case, but in this clustering problem that we only have the x, we don't have any y. So we are trying to understand better human. So when ourselves, we can do the classification. So without any instruction of the yi. So we can just based on the feature itself, we can make this kind of the classification. So this problem we just call it as a clustering problem. So the human, so the scientists are trying to understand what is the underlying logic for that. So there is a very good kind of explanation for that, is that we just put the things with the similarity together. So we just put the similar things together. So just so this is also the most kind of the method. So in the clustering, how they build the method just based on this logic. So that we will put the similar thing together. And how we just quantify the similar, we have a lot of distance. We can do that. Just at least a few of them. And there is some kind of application scenario like the document clustering. So when we're trying to so every day, so now we have a lot of academic research paper, and of course there is no guy can understand every paper. So there is no guy can understand every paper, but it's still we can do some clustering way to just clustering our document. So when a document come, you have no idea about what its category it is, but we can understand what is the similarity between the document. So in this kind of the task, our goal is to find the group of documents that are similar to each other based on the important term appearing in them. So in archive, we have so many kind of documents. So just to give you millions of documents, how you put it into a different category. So whether this document is related to the AI, whether this document is related to math, whether this document is related to physics. So you want to do that. But actually, we cannot just have the label for everything, for every document. So this document clustering is that we only have the document itself. How we do that? So this is the old approach, is to identify the frequently occurring term in each document, such like the word frequency. So how many words it appear. So for example, if this document appears, the AI document commonly will have the deep learning this term, have the transformer this term. So it's just some frequently occurring term. And we can form the similarity between based on this frequency. So we can just record the frequent data, frequent word, and then we can just build such kind of feature. And Rx maybe just stand for the frequency of some specific term. And we can form, and now we can just have the feature for the document, and based on some similarity measure we can define. So we can define the distance between the vector as the similarity, and then we can use some clustering analysis to do that. So this a good this clustering have a lot of benefits that we do not require a human to give the label. It can do it directly. So according to some auto algorithm. Well, so this is the old approach, but nowadays I think you probably can just have a good way to do that. So what is a good way that you can replace this approach? So you also want to do the document clustering. So what kind of good way you could propose? So the good way is that you can just ask your large language model to first give you some read the paper and give you some latent space feature. So you don't need to identify the frequency of the term, the frequency of the term. You can just use a large language model mapping to some hidden feature. It can give you some information about this feature, this document, and then you can use that feature to make the clustering. So the word frequency is a very, very old topic. So in language, the natural language processing 10 years ago, the people just use this word frequency. But now, just because of successful of the LLM, so you can use that way to give you some hidden feature space. And the clustering, the goal is trying to group the similar item together, so without predefined label. So we can just we can just do some customer segmentation. We can also group the new articles, just that I mentioned, and also you can identify the community in the social network. So you can just so the social network just included like the Facebook, like the Twitter. So you can know what is the connection between the people, and you can just based on this connection to identify the community. So we don't know how many community we could have, but we can just put the people within the same community and give them some recommendation for that. So some method we will introduce like the k-means, probably you have used before, hierarchical clustering, and also the spectral clustering. Well, so this is a clustering method. So commonly, when we just compare the classification and the clustering method, we will say, you probably heard about the name, like the classification, we will say it's a part of the supervised learning. And so classification is the supervised learning and clustering is the unsupervised learning. So the key difference is just come from the clustering is that there is no predefined label. And for the classification, is a predefined label. So you probably know why we call it as a supervised and unsupervised. So there are main three categories in the data science: the supervised learning, unsupervised learning, and so they are just the two parts. So you can just you can imagine that when you do a classification problem, you have a if. You are just want to find such kind of f. So you want to use your data to just create this f. this function f. So the supervised learning just to say there are some supervisor told you. So given the x, what is the destination of this x is should be. So give your yi is equal to 1. So just told you your final destination should go to the 1. And give your negative 1 just told you the final destination is negative 1. So you just know how you change your f. So how you change your f to the 1 or negative 1. So this is called as supervised learning. Someone just guide you. So this yi just guide you. So this is just some label just predefined by some expert, by some supervisor, by some others. So this is why we call it as supervised learning. You know what is the direction you should you should finally go to. But for the clustering is that we do not have what is the final goal. It's what is our final goal. We just know the x, and we're trying to put the x with a similar feature together. So in this at this end, so at this stage, that we do not what kind of the final destination it could be. What we can do is that we just put. So of course, group the similar thing together is just one type of clustering. So we just also we want to put our data into several kind of the category, and but well, it's just still have a lot of things to explore it. Wow. So the people why they want to analyze these things is just I mentioned. So when we just develop our method, we just want to further understand what is the intelligence itself. So AI is just trying to understand the intelligence. So this is our human nature that could so we can do that without any, just like this example, we can do it. We can do this classification without any instruction. So we're trying to understand what is the underlying behavior. So we just, this behavior, we could say that we put the things similar together. But there are also some other unsupervised learning method, just told you. There are different kind of logic to build the different model. Well, so I just mentioned the two, but the last one, you probably know what is that. So the supervised and unsupervised, and another is pretty important, famous, is called as a reinforcement learning. So it's just one of my research topic. So that is the way you if you have every if you have just touched each of them, you will find reinforcement learning is more close to the intelligence. Well, and the last description method we will call it as association rule discovery. So this one is not such kind of common. So in most of kind of compared with the previous three. So we just look at what these things want to do. So association rule discovery is we just given a set of the record of each of which contains some number of items given from a given collection. So I just show it's just a little hard to understand, but here I just show what is that. So we have the 5 data, and each data is just a collection of the several kind of item. So for example, in the data 1 it's the bread, Coke, and milk. In the data 2 is the beer and bread.